Today we will be talking about acids, alkalis and the pH scale. Our learning objectives are: how can we test if a substance is an acid or an alkali? Number 2. Why is universal indicator paper better? Number 3. How can we use acids, alkalis and neutralization reactions in our lives? Our keywords are neutralization, pH scale, acids, alkalis, red litmus paper, blue litmus paper and universal indicator paper. How can we test if a substance is an acid or an alkali? If the substance we use blue litmus paper to test if a substance is acid. If the substance is acid, the blue litmus paper will turn red. I will now test if lemon juice is an acid or an alkali. As we can see, the blue litmus paper has turned red. Now we will test if vinegar is an acid. As we can see, vinegar is an acid. Red litmus paper is used to test if a substance is an alkali. Now we will test if any of these substances are alkalis. Now first the color will change into blue if any of these substances are alkali. As we can see, the washing up powder has turned blue. Now we will test milk, bleach. As you can see, the red litmus paper has turned blue. This shows that bleach is an alkali. Now I will use red litmus paper in milk. As we can see, the red litmus paper has stayed red. This shows that milk isn't an alkali. Now we will test milk with blue litmus paper. As you can see, the blue litmus paper has stayed blue. This shows that milk isn't an acid or an alkali. Now let's try it with water. The red litmus paper has stayed red. The blue litmus paper has stayed blue. This tells us that water is an acid or an alkali. This tells us that they're both milk and water are neutral. Another way of doing this is to use a universal indicator paper. Why is universal indicator paper better? Universal indicator is better because it doesn't just tell us if something is an acid or an alkali. It tells us if it's a weak acid or a strong acid or a weak alkali and a stronger alkali. The pH scale has numbers from 1 to 14. Number 1 shows it's a strong acid, number 7 shows it's neutral, and number 14 shows it's a strong alkali. We will now test this using our substances. First, we will test it on lemon juice. As we can see, the pH scale tells us that lemon juice is at number 2. Now we will test this on vinegar. The vinegar tells us that this is on number 3. So vinegar is a weaker acid than lemon juice. Now we will test this on milk. The pH scale tells us that milk is at 7, being neutral. Now we will test this on water. The pH scale tells us that water is at 7, showing us that water is neutral. Now we will test this on washing powder. As we can see, now we will test this on the pH scale. As we can see, it's on 10. Now we'll test this on bleach. The pH is 13. As you can see, it's hard to get an accurate number, so that's why you can use a pH meter. A pH meter looks like this. It gives an exact number on what pH your substance is. How can we use acids, alkalis and neutralization reactions in our lives? A neutralization reaction is when you can add an acid and an alkali together to make a neutral solution. Bee stings and stinging nettles are acidic, so they hurt. If you add an alkali such as bicarbonate of soda, baking soda, to them, then it will reduce the pain. Wasp stings are alkali, so you need to add an acid like vinegar to neutralize it. Farmers add lime and alkali to soil if it is too acidic for the vegetables they want to grow. Thank you for watching my lesson. I hope you enjoyed it and that you understand acids, alkalis and the pH scale. Bye bye.